Aspirin is toxic in high concentrations. That's why aspirin tablet manufacturers must ensure that their product contains between 90% and 110% of the amount of active ingredient stated on the label. Does your brand of aspirin pass the test? In this video, you will learn how to use PASCO's UV-Vis spectrometer to analyze the aspirin content in an aspirin tablet as an application of Beer's law. The solution preparation and analysis techniques in this video can be applied to any one-solute solution that absorbs light between 180 nanometers and 1050 nanometers. You will need a Windows or Mac computer and the latest version of the spectrometry app, which is available for free at pasco.com/downloads. The chemical name for aspirin is acetyl salicylic acid, or ASA for short. You can determine the amount of ASA in an individual 325 milligram aspirin tablet by comparing the absorbance of several colorless ASA solutions of known concentrations against the absorbance of a solution made from an individual aspirin tablet. ASA degrades fairly quickly in solution, so all solutions should be used within an hour or so of mixing. First, mix 100 milliliters of a 2.2 millimolar stock ASA solution. Make this by dissolving less than a gram of solid ASA in 95% ethanol in a volumetric flask. So you will need an analytical balance readable to the 10,000th place. Next, 5 solutions labeled A through E are made by taking 2, 4, 6, 8, and 10 milliliters of stock solution and diluting each to 100 milliliters with distilled water in a volumetric flask. Students must use the dilution equation M1V1 equals M2V2 to calculate the new concentration of each solution based on the volume of stock solution used. Next, a calibration solution is made by mixing 0.8 milliliters of 95% ethanol with 9.2 milliliters of distilled water. And now you can construct the calibration curve for an ASA absorbance versus concentration graph. Use quartz cuvettes for best results. Fill each cuvette 3/4 full. Handle each cuvette by the frosted sides and wipe the clear sides with a lint-free lens wipe before placing in the spectrometer. Orient the cuvette so that light travels through the clear sides from the light source to the detector. Start with the calibration solution. First, calibrate dark, then calibrate light. Next, I need to use an ASA solution to choose an appropriate analysis wavelength. I am choosing solution D since it is neither the most concentrated nor the most dilute in the series. Start recording data and make the adjustments necessary to improve the data display. I'm going to change the number of average scans and increase smoothing. And then I'm going to move the coordinate tool to a distinct peak and select the check mark to set the analysis wavelength. Now stop recording data and go to the concentration tab. The concentrations for each solution are reported in millimolar, so you'll need to change the unit in the table. Millimolar is the same as millimoles per liter. Update the concentration values in the table to match your calculated values for solutions A through E. And start recording data. Starting with solution A, click the check mark to keep that solution's absorbance value. Next, go to B, C, D, and lastly E. Notice all my absorbance values are very close to or below 1 as they should be. I can add a linear fit to get the slope, and I can scale the data. we'll need the slope m and y-intercept b for a later calculation. Now it's time to determine the absorbance of an aspirin tablet solution. To make the solution, first record the exact mass of an aspirin tablet, then grind it to a very fine powder with a mortar and pestle. Measure about 0.04 grams of the tablet powder. Record the exact mass collected. Bring the solution to volume with ethanol in a 100 milliliter volumetric flask, then use a quantitative filter apparatus to remove impurities from the solution. This system uses a simple hand-operated vacuum pump, but your setup may incorporate a water aspirator. Just take 6 milliliters of the filtrate and add it to a 100 milliliter volumetric flask, but this time bring the solution to volume with distilled water. Then add the solution to a quartz cuvette. Record the absorbance of a solution of unknown concentration here in the bottom table in the spectrometry app. Once you have the absorbance, which is the y value from the graph, you can either estimate the concentration based on where the absorbance value intersects the slope, 0.514 is about here, or even better, use the linear equation y equals mx plus b to find the x-axis value, which is concentration. Just plug in y, m, and b to solve for x. You can enter your calculator estimated concentration in this box, and the app will plot the point for you. The closer your data point is to bright green, the closer your value is to the concentration predicted by the linear fit. Once you're confident in the concentration, you can calculate the mass of ASA in the original tablet. Then you can compare that mass to the 325 milligram value stated on the bottle to see whether the aspirin mass falls within plus or minus 10% of 325 milligrams per tablet. For more investigation ideas with the UV-Vis spectrometer or other equipment, visit PASCO.com. Thanks for watching and see you next time.